Imagine a world where humans could control the weather at will. Now, it might sound like science fiction, but in 1946, one man believed he had cracked the code. This is the true story of how his experiments kick-started a wild era of weather manipulation that would change how we view our relationship with nature forever. It's a chilly morning in November 1946, and Nobel Prize-winning chemist Irving Langmuir is watching the skies with anticipation, waiting to see if all of his work has paid off. This is a man with a vision. He was going to be the first person to control the weather. He had a theory that by introducing substances like dry ice into existing cloud formations, he could trigger rain or snowfall on demand. He had tested his ideas in a lab, but he was desperate to see if they would work in reality. And why was Langmuir so excited about this? Well, imagine being able to divert hurricanes away from cities, to end droughts, to prevent floods from ever happening. The potential for this was huge. But as we'll see, Langmuir's journey into weather control took some unexpected turns. Nature, as it turns out, doesn't always play by the rules. So how did a Nobel Prize-winning chemist end up trying to control the weather? Well, Irving Langmuir was no normal scientist. He was the first ever industrial chemist to ever win a Nobel Prize, snagging the award in 1932 for his groundbreaking work on surface chemistry. But Langmuir's brilliance did come with a bit of a quirky side. Langmuir was not only the ultimate embodiment of the absent-minded professor, but he took this expression to a whole new level. There was a time that he was so lost in thought deep in his scientific musings that he didn't notice a woman literally falling over right in front of him. Another time, he actually left a tip for his wife, not noticing that he was at home instead of in a restaurant. But it was this intense focus and curiosity that led Langmuir down a path that even he could never have predicted. During World War II, he found himself working on a scientific problem: ice formation on aircraft wings. While studying this occurrence, Langmuir became fascinated by something called supercooled clouds. These are clouds that stay liquid even when the temperature falls far below freezing. It's the same principle as when you supercool a water bottle and then shake it and watch it freeze instantly. Now, this discovery got Langmuir thinking. If clouds exist in this delicate balance between solid and liquid, could we somehow tip the balance one way or the other? In other words, could we make it rain or snow on command? Now, considering he wasn't a billionaire industrialist, you might be wondering, how did Langmuir have the freedom to pursue such wild and crazy ideas? Enter General Electric, Langmuir's employer. GE wasn't your average company. They had a policy to allow their researchers to work on whatever interested them, even if it didn't have any form of practical application. Imagine having a job where your boss goes, "Hey, you want to figure out how to control the weather? Go for it." That's basically what happened with Langmuir. This freedom proved crucial. It allowed him to pursue his scientific interests without having to worry about immediate results or financial returns. With GE's blessing, Langmuir and his assistant Vincent Schaefer set up shop in a lab and set to work. So, as I've mentioned, they wanted to see if they could create snow by introducing various substances into a controlled environment. At first, nothing seemed to work, but then they had a breakthrough. When they introduced tiny particles of dry ice into their artificial supercooled clouds, something incredible happened. Ice crystals began to form. Langmuir would later describe it as watching the birth of a snowflake in real time. This success in the lab was exciting, but Langmuir knew they needed to think bigger, much bigger. That's what led to that chilly November morning at Schenectady Airport, with Langmuir and his team nervously watching the skies above. Langmuir and his team were about to take their experiments from the controlled environment of the lab to the wild, unpredictable skies above. The stakes were enormous. If they could prove cloud seeding worked on a large scale, it would change absolutely everything. Drought-stricken farms would be able to get the rain they desperately needed. Cities threatened by severe storms would be able to weaken them before they hit. The implications for agriculture, disaster prevention, and even warfare were absolutely staggering. As Langmuir watched that small plane take off carrying just 6 pounds of crushed dry ice, he must have felt a mixture of excitement and anxiety. This was the culmination of months of lab work, theories and wild dreams, and it had never been done before. As the plane climbed, Langmuir's mind must have been racing. But the experiment didn't start smoothly. The motorised dispenser they'd built to release the dry ice jammed in the cold and just didn't work. But Schaefer wasn't about to let a technical hitch stop them. In a moment of quick thinking, he did something both simple and daring. He opened the plane window and started simply throwing handfuls of dry ice out of the window. As Schaefer released the dry ice into the supercooled cloud, Langmuir watched from the ground, his eyes glued to the sky. Would something happen? Would anything happen? Minutes ticked by, feeling like hours. Then, finally, something did happen. From miles and miles away, Langmuir finally spotted it. Snow, real-life snow, forming right in front of his eyes. Far from the ancient world of rain dances and rituals, Irving Langmuir had become the first human in history to successfully instigate a real-life weather event. Now, you might be wondering, how does this actually work? Well, it's all about giving these water droplets a little nudge. You see, in supercooled clouds, water droplets can stay at liquid temperature even far, far below freezing because they simply don't have anything to freeze onto. It's kind of like nature's version of procrastination. I mean, the water knows it should freeze, it just hasn't got around to it yet.
When you introduce something like dry ice, it gives those water droplets a surface to start forming ice crystals on.
It's like throwing a pebble into a still pond, except in this case the ripples are the ice crystals that grow into snowflakes, and they then start a chain reaction converting all of the water droplets into snow. The success of this experiment was mind-blowing. In a moment of excitement, Langmuir proclaimed, "This is it, mankind has finally learnt to control the weather." It's a statement that perfectly captures the optimism and maybe a touch of the hubris of the time. Suddenly, the possibilities seemed endless. Could they create snow for ski resorts on demand, steer hurricanes away from populated areas, create rain on demand for drought-stricken farms? The dream of weather control no longer seemed like science fiction. It suddenly felt tantalisingly within reach. But here's where things get interesting. Whilst Langmuir and his team were riding high on their wave of success, not everyone was as enthusiastic. The legal team at General Electric, where Langmuir worked, started raising concerns. What if their weather manipulation had unintended consequences? Who would be liable if something went wrong? These questions highlight an important point. Scientific discovery doesn't happen in a vacuum. It has real-world implications that go far beyond the lab. The ability to control weather events isn't just a scientific achievement. It's a power that comes with enormous responsibility. Langmuir's successful cloud seeding experiment seemed like a dream come true, but as with many dreams, reality had a way of complicating things. After their initial success, Langmuir and his team conducted more cloud seeding experiments, hoping to refine their technique and prove its reliability. But instead of controlled snowfall, they got something quite different. Some of their experiments triggered heavy snowstorms that caught everyone off guard. Imagine you're a resident of a nearby town, expecting at most a light dusting of snow. And then you wake up the next morning to find your house covered under feet and feet of the stuff. That's exactly what happened in some areas affected by these experiments. These unexpected blizzards caused all sorts of issues, power outages, road closures, and all sorts of chaos. Now you might be thinking, isn't this exactly what they were trying to do? Well, yes and no. They wanted to prove that they could make it snow, but they didn't intend to create full-blown winter storms. It's like the difference between watering your garden and accidentally flooding your neighbourhood. These unintended consequences were what had prompted General Electric's legal team to start asking some pretty uncomfortable questions. What if someone's property got damaged during one of these artificial storms? Who would be responsible? Could the company be sued? This is where things took an interesting turn. To avoid potential legal issues, General Electric teamed up with the one organisation who they knew were equipped to conduct large-scale, risky operations: the US military. With the armed forces on board, Langmuir and his team set their sights on an even bigger target: hurricanes. They theorised that by seeding hurricanes with dry ice, they may be able to either weaken them or even steer them away from populated areas. It was an ambitious idea, to say the least. On October 1947, they got their chance to test this theory. A hurricane, which would later be named Hurricane King, was moving at pace through the Atlantic, and military planes were immediately dispatched to drop dry ice into the storm. The team watched and waited, hoping to see the hurricane either change course or lose power. What happened next was both unexpected and alarming. Instead of weakening, Hurricane King seemed to gain strength. The results were devastating. Hurricane King slammed into the coast with extremely powerful winds and storm surges. Lives were lost and the damage ran into the billions and billions of dollars. It was a reminder of just how harsh and unpredictable nature can be. This event marked a turning point in weather control experiments. The US Weather Bureau, which had been skeptical to begin with, became even more vocal in its criticism. They emphasised the need for rigorous statistical analysis rather than anecdotal stories or one-off experiments. Vincent Schaefer, Langmuir's longtime assistant, the one who had thrown ice out of the aeroplane all the way back in that first experiment, had a particularly harrowing experience. As he flew home after the Hurricane King experiment, the extreme turbulence caused by Hurricane King nearly took down his aeroplane. It was a stark reminder of the storm's unexpected power and intensity. Despite these setbacks, Langmuir still remained optimistic about his project. He continued to make optimistic predictions about their ability to manipulate hurricanes and other weather phenomena, but his optimism was at odds with the growing caution of other members of the scientific community. As more experiments were conducted, officials started asking more and more questions about the ethical and environmental implications of messing with the weather on such a large scale. But before we dive into those concerns, we're going to take a slight detour. This is Bernard Vonnegut, brother of famous author Kurt Vonnegut. In 1947, Bernard made a discovery that would expand the possibilities of cloud seeding even further. He found that silver iodide could be used as a much more effective cloud seeding agent. Why was this a big deal? Well, silver iodide had some major advantages over dry ice. It could be dispersed more easily and in smaller quantities. This discovery opened up whole new avenues of weather modification research. But it also raised some new questions. How would these tiny particles affect the atmosphere in the long term? Could there be unintended consequences that we hadn't considered? While American scientists were grappling with these questions, on the other side of the world, Soviet researchers were dreaming much bigger. In the 1950s, Soviet climatologists proposed some truly astounding climate modification projects. We're talking about plans to do things such as melting the Arctic sea ice. Their goal? To warm up the northern latitudes and to make it more habitable. These ideas might sound a bit out there today, but they illustrate just how grand the ambitions for climate modification were during this era. In fact, a 1960 Soviet book entitled Man vs. Climate boldly stated, "Presently available power resources and technological possibilities permit us to remake the climate of entire regions of the world." But as time went on, the initial enthusiasm for weather control began to wane. Scientists began to realise just how complex climate systems really are. The idea that we could simply tweak the weather like adjusting a thermostat began to seem naive at best and dangerous at worst. This shift in attitude brings us to the modern debate about geoengineering. Today, we're not so much trying to control the weather as we are desperately trying to mitigate the effects of unintentional climate change. Some researchers are looking into things like negative emission technologies, which aim to remove carbon dioxide from our atmosphere. Others are looking into solar radiation management, which aims to reflect some of the sun's energy back into space. But here's the thing, these modern geoengineering projects face just as much, if not more controversy than the grand weather control experiments of the past. Why? Because we've learnt the hard way that when it comes to the Earth's climate, everything is connected. Change just one thing and you might set off a chain reaction of unintended consequences. That's not to say all research into climate intervention has stopped. In fact, the urgency of the climate crisis has led to a renewed interest in some of these ideas. But the approach is much more cautious now. Scientists are acutely aware of the potential risks and are calling for careful, controlled studies before any large-scale interventions are attempted. It's a far cry from the optimism of Langmuir's era. Back then, the prevailing thinking was, if we try, we're sure to succeed. Now it's more like, if we try, we're bound to mess up. This caution reflects our growing understanding of the complexity and delicacy of Earth's systems. So what can we learn from Langmuir's wild weather experiments? Well, for one, nature is way more complex than we thought. Those early experiments were a bit like trying to conduct an orchestra when all you've ever done is play a triangle. But we haven't given up on tweaking the climate. Today's scientists are exploring geoengineering not out of optimism, but desperation. Climate change has us backed into a corner. As one researcher put it, we've left it so late that all that remain are a set of bad options. It's a far cry from Langmuir's naive enthusiasm. Now we're asking questions such as, if we try and fix the environment, who is it that decides what fixed looks like? And what if our cure is worse than the disease? The weather control dream isn't dead, it's just grown up, realising that with great power comes great, oh crap, what have we? And on the subject of having power, if you've liked this video, you have the power to let YouTube know by liking, sharing, and subscribing. I'll see you next time.